Hi, in this video, we are learning how to solve linear inequalities. In the last two chapters, we only learned how to solve linear equations, which involves the equality between two expressions. Now, an inequality is a statement that one expression is less than or equal, greater than or equal to another expression. For example, if you look at this for example here, we have ax plus b less than c, or less than or equal to c, or bigger than or equal to c. Now we are trying to solve for x in these four cases. So that's why we call this is a linear inequality instead of linear equation, as comparing to the last two chapters. Now, for the interval notations, we can represent the solutions of any inequality by using the interval notations. For example, if I say something is less than a and less than b and bigger than a, I'm saying that x is between a and b, so that's why we are using the parentheses to represent for the solution of this case. So if I write this a comma b, open parentheses and close that means x is now in between a and b. And for the second case, I'm using the bracket instead of the open parentheses. The reason I'm using the brackets because in this case here, we also include the equal sign at the right side. So the last case, x is less than b, we are using the open parentheses. But now x is less than or equal to b, we are using the bracket. The brackets mean that we include the endpoint for b, but this one we do not include the right endpoint. That means any value of x up to b, but not including b. But here, any value of x less than b and also equal to b, that means we include the right endpoint, or we are using the bracket. The same thing here, if we have all the equal sign on the left and the right, then we have to use the brackets for both of the sides. So x is between a and b, and we also include a and include b for the two endpoints. The same thing to the last case here, we have x bigger than or equal to a, but then only less than b because we don't have the bracket here, so we don't include the equal sign in this case. For the next few cases, we consider that x is all the number that is less than a. So if x is anything that is less than a, that tells you that a is the highest the value. So we're using the open parentheses, and that means all the x is less than a, so it's go up all the way to a, and then it stop at a, but not including a, before a. And then anything that less than a, so it's all the way to the left of a, we can go all the way to negative infinity. That means a very huge negative number. For the parentheses, for the infinity, we only use the parentheses for the infinity. We do not use the brackets for the infinity because we cannot include the infinity or something that is not defined, a very large number. So that's why we do not include the left endpoint here. We're only using the parentheses for infinity symbol. And for anything is bigger than a, we can write as, so a is the smallest value, and now we have all the value that is bigger than a. That means we go all the way to the left of a up to infinity, which is a very large or huge positive value. And we have a similar case here, but we include the endpoint. That means all the value of x less than a and up to a. So we have the right endpoint for a, and all the way to negative infinity to the left side. Remember, we don't use the bracket for the infinity. And the same thing to here, a up to infinity. That means all the value of x is bigger than or equal to a, and go all the way to the right to positive infinity. Remember, here we have 0 on the number-line system. If you go all the way to the left, very far to the left end here, you are approaching to negative infinity, and all the way to the right is positive infinity. All real numbers is written in inside the parentheses using negative infinity to infinity. So for all real number, that means all the number on the number line system. That means we have all the way to the left here and go up all the way to the right up to infinity. So negative infinity up to positive infinity, and we only use the parentheses for infinity symbols. Now let's try one example to the first example to write each inequality here in the interval notation, and then graph the interval. So all the value of x that is less than a, so x is less than 3. So here we can write any the interval notation. So all the value of x are less than 3. So 3 is the highest value on the right side, and because we have the equal sign, so I'm using the bracket. And then all the value of x to the left of 3, or we can go all the way to negative infinity. So if you graphing this one on the number line system, let's say we have 0 here, we have 3 here. So all the value that are less than 3, that means we draw the line from 3, and then all the value to the left of 3. So we can put the error here. So the error, and then just pointing to the left. That means all the value of x that are less than 3, and it's only go up to 3 only. Now because we have the equal sign as 3, I'm using the solid circle. If we don't have the equal sign, then I'm using the open circle. Let's try this example here. Any value of x that are bigger than minus 3.3 over 2. So minus 3 over 2 is the smallest point, and all the value of that is bigger than minus 3 over 2. So we go all the way to the right of that up to infinity. And because we don't have the equal sign here, I'm using the open parentheses. Now you graph this on the number line system. We know this is 0. Somewhere here is minus 3 over 2. We don't have the equal sign, so I'm using the open circle. If we have the equal sign, I'm using the closed circle or solid circle. Now all the value of x that are bigger than this value, so it's bigger than, that means we go all the way to the right. So this is the graph for the line. All the value of x that are bigger than minus 3 over 2 all the way to the right. In this case, it's less than, so all the way to the left of 3. Okay, there's two important properties for inequality. The first one is the addition property. So if there are number a, b, and c representing the real numbers, then the inequalities a is less than b anytime that you are adding a c to one side, and if you are adding the same c to the other side, then we also have another equivalent inequality to the original inequality. That is, the same number may be added to each side of an inequality without changing the solution set, because the two forms here, they are all equivalent. If you add something here, the left, and do the same thing to the right, you are not changing the solution set. However, for the multiplication, if you multiply a positive value c on the left and the same thing to the right, then they are equivalent. However, if you multiply by a negative value of c to both sides of the inequality, then you must reverse the direction of the inequality in order for the two inequalities to be equivalent. So let's just summarize here. If you multiply or divide both sides of an inequality by a negative number, then you must reverse the inequality side, or else you are changing the solution set. Let's just do one example for this case here. I have 2 less than 3. Okay, so let's say I have 2 less than 3. 2 stands for A, 3 stands for B. Now, if I multiply by a c, a negative value, so let's say I multiply the left and the right side by -2, and I don't reverse the direction, I keep that the same. So 3 multiplied by -2. So now we got 2 times -2, which is -4, and 3 times -2 is -6, and -4 is less than -6. It is the right inequality. Let's check this. We have 0 here, we have -4, and -6 is to the left of -4, and this inequality is saying that -4 is less than -6, which is not right. -4 must be bigger than -6. Therefore, if you multiply or divide by a negative number, you are talking about in the negative region, and the more you are going to the left, the more you are smaller than to the right. That's why we have to revert the direction if you are multiplying or dividing by a negative value. Okay, solve Is Inequality here, and then write a solution set in the interval notation and also wrap it. So we do the same thing as we are solving for x for the equation. So the first thing is you just ignore the inequalities, just subtract 7 on both sides. We have 6x less than or equal to -24, -17 minus 7 is -24. Now to isolate the x, dividing both sides by 6, because we are dividing by a positive value, we are not switching or reversing any of the inequality here. So I keep the same direction. So x -24 divided by 6 is -4. So my solution here is all the value of x that are less than or equal to -4. So -4 is the highest value, and then all the way to the left up to -infinity. This is my solution. So all the value of x that are less than or equal to -4, so they go all the way to the left and they hit the -4 with a bracket of the equal sign here. And if you are to wrap this on the number line system, we can do that easily here. We have -4, 0 here, so -4 is here. So all the value of x that are less than to -4, so with an equal sign, so we are using the open closed circle, and then go all the way to the left of -4 because we are less than -4. Okay, let's try the next one. In this case, we are solving for the w. The first thing is you have to simplify this one by distributing the 3 to the inside parentheses here. So -4w plus 4 times 3 is 12. 3 times 3 is 9w. Keep the same here. W plus w, combine the like term 2w plus 9. Now also combine the like term here. 9w minus 4w is 5w plus 12. And then rewrite the whole thing down here. And now we are subtracting 2w on both sides. So we want to remove this one here. I got 5 minus 2w is 3w plus 12 bigger than or equal to 9. We want to isolate the w, so I subtract 12 on both sides. Take away the 12, I got 3w bigger than or equal to 3 minus 12, that is minus 3. And now you want to solve for w, so you must divide by 3 on both sides. And that take the 3 on the left side. Minus 3 divided by 3 is minus 1. So all the value of w that are bigger than or equal to minus 1. So minus 1 is the smallest value. And we go all the way to the right of that up to infinity. So this one is your answer. And if you want to wrap this on a normalized system, we can do that easily here. 0 is here, minus 1 is here, and this is the also the equal sign. So I'm using the closed circle, and any value that are bigger than minus 1, so we go all the way to the right of minus 1 up to infinity to the right side. Okay, let's move on to the next example. In the last few cases, we only dealing with two sides of an inequality. Now, there is something called a three-part inequality. That means we have two inequalities as once. So if x is bigger than a and less than b, this means two things. This means that x is bigger than a, and also x is less than b, right? X is bigger than a, and at the same time x is less than b. Now, it's basically the same thing as just one side inequality. We just now have three different sides as comparing to two sides before. So now let's try one example, and hopefully this will make sense to you. So solving this inequality here, we have minus 7 less than or equal to 3x minus 4 and less than or equal to 8. Again, you are trying to isolate the x on the middle here. So the first thing is you want to isolate the x in the middle and solving for x. That means you want to take away the 4 here. So minus 4 and then add 4 to 3 sides. Again, if you do something to one side, make sure you do the same thing to the other two sides. So add 4, that take away the middle 4. So 8 plus 4 is 12, and then keep the same symbol. We have 3x in the middle. Minus 7 plus 4 is minus 3, and then keep the symbol here. You are trying to solve for x, so I want to isolate the 3 here by dividing 3, and also the same thing to the other two sides. So 3 is gone in the middle, that's why we are solving for x. And now 12 divided by 3 is 4, minus 3 divided by 3 is minus 1. So we end up with a solution that all the value of x that are less than or equal to 4 and bigger than or equal to minus 1 are the solution to this inequality. And of course you can write this in the interval notation. The smaller value is minus 1 and the upper value is 4, and they all have the equal size, so I'm using both of the bracket on the left and the right endpoints. And you can also wrap this one on the normalized system. So let's say I have 0 here, minus 1 is here, and then 4 is here. So we have the bracket. That's why we have a closed circle on the two sides. And all the value between minus 1 up to 4, this one should be the solution to the inequality here. Let's try another example B. Again, we are trying to solve for x, so the first thing is you want to get rid of minus 1 here by adding 1 on 3 sides. So let's take away the 1. I have 2 over 3x less than 8 plus 1 is 9, minus 4 plus 1 is minus 3. You are trying to solve for x, that's why you want to multiply by the reciprocal of 2/3 or 3 over 2 to all the sides. And now 3 and 3 they cancel, 2 and 2 they cancel. Therefore, you have x now in the middle by itself. 9 times 3 is 27 over 2. 3 times 3 times minus 3 is minus 9 over 2. So, and then we have the inequality here. Now the left endpoint is minus 9 over 2 with the equal sign, so which is a bracket, and the right endpoint is 27 over 2, and we don't have equal sign, so I'm using the open parenthesis. So this one is your solution. So this tells me that on the normalized system, this is 0, this is minus 9 over 2, this is 27, something like that, over 2. So your solution is between minus 9 over 2, the bracket, so I'm using the closed circle. This one is the open parenthesis, I'm using the open circle. So your value should be between this thing here all the way up to 27 over 2. So this region here is your answer, or your solution to this inequality here. Okay, the last example here, we are trying to translating the phrases to inequalities. So here we have a number is more than 4, so we call that number to be x. So it's more than 4, that is bigger than 4, so we have x is bigger than 4. So this is how we translate the phrases to inequality. Now a number is less than 12, again a number is, we use x to represent for the number, and it's less than 12 or less than 12, simple. A number exceeds 3.5, exceeds is meaning the same thing for is bigger than, right? So x is bigger than 3.5, or at least that means it's greater than or equal. So x is bigger than or equal to 6, because at least that means you also including the value for 6. That means we are using the equal sign at 6, and then all the way to the right of 6. At most, that means the highest value is 8. So 8 is the highest value. So something less than or equal to this one, or 8. Make sure you have the equal sign as well for at most. With that example here for translating the phrases, now we can try on the word problems. So the first word problem here, a student scores 92 and 78 on his first 2 tests. What possible scores could he make on his next test so that his average is at least 80 points? So we are looking for the possible score, and we don't know that, so I let that to be x, and we want the average to be at least is bigger than or equal to 80. Okay, now we know we want his average to be at least, and we can find the average scores by adding the 3 score, the first 2 score of his first 2 tests, and then the next one for the third one, and dividing by 3 for the average. So the first one is 92, the second one is 78, the third one we don't know yet, that's why we let that to be x. Now the average of these 3 by taking the 3 sum and divide by 3. So this one is the average, and we want this average here to be at least or bigger than or equal to 80. And now we are looking for this possible scores here, or we are trying to solve for x for this inequality here. You can solve for x by first multiplying both sides by 3, because 3 and 3 here cancel. So the left side have 92 plus 78 plus x is bigger than or equal to 80 times 3 is 240. Combine the right term, 92 plus 78 is 170 plus x, and it's bigger than or equal to 240. Now you want to solve for x, that means you are subtracting 170 on both sides. So that's taking away 170x is bigger than or equal to 70. So this tells me that as long as his Turk exam has at least the scores for 70 or higher, then the whole average should be bigger than or equal to 80. So this tells me that he needs to get 70 or better on his Turk exams or tests, because we want at least 70, so 70 or better on the Turk exam to be able to get to the average score of at least 80. Okay, let's try. Okay, so that is the last example for this section. So basically, we are just using the inequality and set up the problem from the statement and then solving for that inequality. And remember, for the inequality, we have many solutions comparing to the equation. For the equation, when you are trying to solve for x, you just get one solution for x. But now we get something bigger than 70. So I can say I have 70 is the correct answer. 71 is also a good answer because 71 is bigger than 70. Or 85.2 is also the solution because 85.2 is bigger than or equal to 70. So as long as something is bigger than or equal to 70, then it is the solution for the problem that you're looking for. How about let's try to plot this one on the normalized system. So 0 is here, so 70 is here. This is the equal sign as 70, so I'm using the closed circle. So all the value from 70 and to the right of that should be the solution to the problem here. Or you need to get at least 70 or better on the Turk exam in order to get the average of at least 80. And that is the end for this section 2.8. And thanks for watching.